Another important way that we can analyze glass is by looking at the glass fracture patterns. So when you hit glass, it's going to make a ring in it. It's going to make cracks in it. And if I hit a glass by a projectile, so a bullet, a rock is thrown through it, it's going to produce cracks. And those cracks are going to move out from, like from the initial area where it's been hit. It's going to radiate outward in two different ways. So I have radial fractures, and these are ones that go straight out like rays from the center. And then I have concentric. These are the ones that are more like circular, that kind of have like echoes, like ripples when a stone hits the water. And from these, I can determine the direction of impact. So when an object hits a piece of glass, that's going to push that glass forward, right? So in the way this picture is showing, it's pushing this glass forward, and we see what we first start to get is on the back side of the glass. Here you can kind of see it here. That's where the pressure is the greatest, is on the back side, because that's the part that's being pushed out the most, as this has the glass piece has to kind of bend to accommodate this thing hitting it. So you're going to get on the opposite side these radial cracks, the rays that just kind of go out in all different directions straight out from the crack. And then on the same side that the force came from, we're going to see these radial. You can see now you're going to see these concentric. I said radial, I meant concentric right here. So on the same side, I'll see the concentric circular cracks on the glass. So by looking at that, I can tell which side the piece of glass was hit from. Another thing that happens is if I have a pretty high velocity projectile, so mostly more like bullets we're thinking, or it could be shots from a shotgun, but something very fast. If it often leaves a hole that's wider at the exit side, and that is going to help me in determining this direction of impact. So what we find is that the radial cracks form a right angle on the reverse side of the force. Now, what do we mean by that? If we look at this piece of glass was hit from the direction on the right, and we notice as we look at these patterns, and they don't look like little L shapes, they kind of look curvy. But if I look on the left side, these waves are kind of perpendicular to the edge. We're going to say it's a right angle on the reverse side. On the side that it was hit, they're more like parallel. They're more going straight up along the side of it. And so from that, we can say that this direction. So if I were just observing this pattern, I could tell that this was hit and the force was originating from the right side. Additionally, oftentimes we get more than one crack, and I need to know, well, what was the order of events? Which crack came first? If it was bullet holes, I'd want to know the sequence of which was the first bullet hole. And so I can tell that because as we get these radial cracks, they're going to terminate if there's already a line of fracture there. So if I have a radial fracture and then I get a new one and it's kind of edging out, when it hits the other one, it stops. So I can detect this pattern. Let's look at this piece here. So here, this one was the first one. I see a concentric crack and I see a bunch of these radial cracks. And when I look in this direction, note that this radial crack keeps going after you see it past the other one. And this one keeps going. So these ones were here first. When this second bullet hits, I now see these radial cracks continue on, but when it hits the existing one, it stops. When this one hits the existing one, it stops. And so based off of which one is doing the stopping, that's the later fracture.